Good morning to one and all present here. First of all, I wish Happy New Year to all of you. I, Chanda Kumari, PhD scholar,
And I, Mahima Verma, Master's first year,
takes this immense pleasure to welcome you all on behalf of Center of Excellence in Disaster Mitigation and Management in the inaugural session of FORESEED.
To make the starting of this event, I would like to welcome and invite all the dignitaries to come on stage and occupy their respective positions. I welcome Professor K.K. Pant, our Honorable Director, IIT Roorkee, Professor D.S. Arya, Dean Administration and Joint Faculty at Center of Excellence in Disaster Mitigation and Management, Professor Sumit Sen, Head of Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, Dr. V.K. Soni, Head of Environmental Monitoring and Research Center, India Meteorological Department, New Delhi, and Professor Piyush Srivastav, Assistant Professor at the Center, IIT Roorkee. We are honored to have you all, sir. Ladies and gentlemen, let's have a huge round of applause for our respective guests.
Moving on, I would like to request Professor Sen, Heads Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, to welcome our guest of honor, Professor K.K. Pant, Honorable Director, IIT Roorkee, with a lovely bouquet. Thank you, sir. I further request Professor Sen to welcome Professor D.S. Arya, Dean Administration, Joint Faculty, CoEDMM, with a bouquet. Thank you so much, sir. I once again request Professor Sen to welcome Dr. V.K. Soni, Head, Environment Monitoring and Research Center, India Meteorological Department, with a lovely bouquet. Thank you so much, Professor Sen. We are delighted to have you all, sir. Ladies and gentlemen, once again, let's have a huge round of applause for all our guests sitting on the dais. And of course, our lovely student who has come so far from all the corners of this country to be a part of this FORESEED event.
Now, I would like to call Professor Piyush Srivastav, Assistant Professor at the Center of Disaster Mitigation Management, to give a brief introduction about this event. Over to you, sir.
Thank you, Chanda and Mahima. Respected dignitaries on the dais, colleagues, students, and my dear friends. It is with the great pleasure that I am able to start off this new year by welcoming you all to the inaugural session of the Forecasting and Early Warning of Extreme Events and Disaster, that is FORESEED workshop, conducted by the Center of Excellence in Disaster Mitigation and Management, IIT Roorkee. This Karyashala event is being organized under the Accelerate Vigyan scheme of the Science and Engineering Research Board, Department of Science and Technology, Government of India. This event aims to introduce the participants to the next generation mesoscale numerical weather prediction model, commonly known as Weather Research Forecast Model. For the next few days, you will get hands-on experience of using this particular model, its installation process, and how to carry out simulation and post-process the model output in case of extreme weather events. You will also expose to the dedicated training sessions on the landslide modeling and early warning system under the experts in this field. We are glad to see that we have 15 participants from all over the country from various educational backgrounds here today to begin this journey with us. With this brief introduction, let's kick start the event by lighting the lamp. Thank you.
I request everyone to please stand in their respective seats and please we remain standing, and as it will be followed by the Institute Gulgeet. The brilliance of lamplight brings auspiciousness, health, and prosperity and destroys inimical feelings. I now request our guests and audience to please take their respective seats.
Now, I would like to call Professor D.S. Arya, Dean Administration and Joint Faculty at the Center, to kindly come forward to give us a deep insight about 175-year celebration of IIT Roorkee. Over to you, sir.
Honorable Director, Professor K.K. Pant, Head, CoEDMM, Professor Sumit Sen, Head, Dr. Soni from IMD, and Piyush, the course coordinator, my dear colleagues and participants. A very good morning and wishing you all a very happy new year. I've been asked to speak more about the 175-year celebrations. Water and climate. Two things are there which are there in the roots of this institute. Let me tell you, this institute is the mother of engineering education in India. I will also would like to apprise you that this is the oldest institution in Asia and second oldest engineering institution in the world. The first one was in France and the second one is here. So the journey started with the climate. However, climate has given a less emphasis here and water got more. The journey started when there was a famine in 1820 in southern India, and Britishers thought that they will lose lots of revenue in this fertile land here in North India, and they came up with the idea of constructing a canal, and that's how the construction of the upper Ganges canal started, and it was a 500-kilometer long canal. It started from Haridwar going up to Kanpur, providing irrigated water to this entire area. The construction was started in 1836 and it was completed in 1847. For the requirement of skilled manpower, they started a school here in the year 1847. I mean, it was formally in 1847, and that is the beginning of this institution. So the journey of 175 years started in 1847, and the name of this college was Thomason College of Engineering. And since then, the institute started growing and different branches were emerged here, and in somewhere around 1920 the military engineering services was taken away and what was left here was the civil engineering, and that's how civil engineering name was given to the engineering. And this military engineering services went to another place called MES College in Pune. Then in 1950, after going through different names, Thomason College of Engineering, Thomason College of Civil Engineering, it became the first technical university of India with the name University of Roorkee. When in 1960 IITs were created, the then Prime Minister Jawaharlal Nehru offered to be the first IIT of this country, but the then Chief Minister of our province, state, Uttar Pradesh, Pansab said, no, it is a jewel in our crown, so we are not going to give it to the federal government or central government. And that's how we remain as University of Roorkee until the year 2001, when the institute was raised to the status of Indian Institute of Technology, Roorkee. And the 175 years were completed in 2022. The year-long celebrations of 175 year were started on 25th November 2021 and were completed on 25th November 2022. In this one-year-long celebrations, we have done many activities like the academic seminars, conferences. There were more than 40 academic seminars and conferences organized to celebrate the 175 year. We have taken many initiatives to celebrate it, like the Tax Aarti. Tax Aarti was an initiative to support the local industries. As you might be knowing, this place is very famous for surveying instrument and related civil engineering related industries. So to boost, to give them a support, the Tax Aarti program was initiated. In order to bring the school and colleges with us together to start or to celebrate this journey, a program was started to bring all these school children, college going students to the institute. And year long, there were many such programs that were organized. Then there were activities like we have organized many workshops in India as well as outside with the help of alumni or base of the institute. It was in Nepal, Indonesia, Thailand, it was in UK, Germany, Ethiopia, and many those places where the representation from the institute has gone, as well as the alumni of those areas were together, and they were celebrating the 175 year. Finally, the celebration has reached to its to the peak, and it was the 25th November 2022 when our honorable speaker of our Lok Sabha, Om Aditya Birla ji, was here, and he released the commemorative stamp of 175 year, as well as the commemorative 175-year coin of the institute, and that is how it was completed. So these glorious 175-year past is something that will keep motivating you to learn more here and to know more about the institute. One more thing that I really would like to tell you, and which is related to this particular course, if you I'm very sure you at some point will speak about it, that the measured observations were started in 1860. And the canal was constructed prior to that. So you can imagine what kind of data they might have used for the design of the canal, which is still, canal is there and all these structures are safe, number one. Number two, we still have one of the observatory, very older observatory located very close to the main building. So those data are still there. So I'm sure Piyush sometime will take you there and will show you those observatories also. So thank you very much and enjoy your stay here. Try to learn more about the institute and all the very best to you. Thank you.
Thank you so much, sir. Indeed, we are also proud to be the part of IIT Roorkee. Now I request Professor Sen, Head CoEDMM IIT Roorkee, to please share few insights about the center. Over to you, sir.
Thank you, Chanda, and very good morning to everyone, and I wish you a very happy new year to everyone. And I really want to thank Professor Pant to really take out some time on the first day of this year for this event. I really appreciate and really thank you for. And he's busy. He's also taking a flight in soon. So, but I really want to thank you. Also want to thank you, Professor Desaria and Dean Administration, plus also the joint faculty of our CDM. To every time he has been supporting our center's activity, I really want to thank you for that. And Dr. Soni to come down for all the way from IIT Delhi, we want to thank you for that. And Dr. Piyush to really take this initiative forward. And not taking much of the time, I just want to say that it's a privilege to have you all the participants from all the part of the country, and we are really excited to have you all on campus. And I want to say that just to brief you about our center, and not only the participants, but I was mentioning Professor Pun that we are live streaming right now. So friends who are online watching us. So we are basically interdisciplinary center. So Center for Excellence in Disaster Mitigation is an interdisciplinary center started in March 2006. And the idea of this center is to focus on to the natural hazards which are occurring in this region, as well as other part of the country. To develop our human resources, to understand the science behind those natural resources, plus also to develop our in-service candidates who are working in this disaster management and mitigation areas. So this center basically has been supported by 3 of our core faculty who have been sitting in our center, but also very well supported by our 17 joint faculty from various departments of IIT Roorkee, starting from architecture till management. So all the parts of the disaster and mitigation management has been covered by support of our different faculty. We are basically also running our MTech and PhD program. So we give masters in disaster mitigation management of 2-year program, as well as we have a PhD program running in the center. And I'm also happy to say that when it started in March 2006, this was the first degree program which started in disaster mitigation management in India. But now we do have different programs running in different institutions who are giving the masters and PhD in disaster mitigation. And as you all know that, as Dr. Arya just mentioned, that our institution is basically built on like water and climate. And as you all know that its climate is really playing a big role nowadays towards our society. Uh, it's on the bad side of it. We are really seeing a lot of extreme events happening, and that brings a lot of disaster happening onto this earth. So in line with that, center, I'm really excited to tell that our center has been basically hosting one of the first operational earthquake early warning system, which has been developed and housed in the center. So I will encourage you all, when you are on campus in the center, please do visit our earthquake early warning system lab, which is a live real-time earthquake system, which is to monitor it, to send a signal out for the society. And our another notable project which from our center, which is we have been developing, is also onto the real-time territorial landslide early warning system. It is in the innocent state, but idea is to basically to develop a operational system, early warning system for landslides, which have been triggered by rainfall extreme events. So I will really encourage you all, and there are many other research projects which are funded from different ministries. Just to name is the Uttarakhand State Disaster Management Authority is funding this big earthquake early warning system, but also our faculty has been supported by different ministries from ISRO and from the disaster management program, but also from DSTs and all. So I would really encourage you all to meet our faculty in campus, as well as from the other departments. You will see various faculty from our different department who are associated to our center. Please go and take this time out and meet people. And I'm very sure you will develop your network. And we might also see you guys, if you're masters, we might really see you as a PhD student coming to the center or to our IIT Roorkee in other department. If you're a PhD, we would we might have you as a faculty. So you're welcome to interact and to develop a network during this 1 week. And just to mention one or two major things, what our center is also hosting. And if you are working in disaster area, you might have heard there is a program called, or a consortium and network is there. It's called Global Alliance for Disaster Risk Institute. So we are a member of it. It's a global network. Our center has been also hosting a South Asian Alliance for Disaster Research Institution. So center is the headquarter of this strategy group, where we are putting all the research institutions who are working in Southeast Asia towards disaster management. So we are hosting that. So there are lots of various activities are going on. So I will also request all the participants to go to our website and see what are the different activities are going. And we are really fortunate to have a lot of good students from PhD and MTech, and their success in different parts. We will see students getting the PMRF fellowship from our center, students getting the travel grants to attend lots of international conferences. So I really excite you to be a part of the center in the long term. So I really welcome you to the IIT Roorkee campus. And with this, a few words, I would like to thank you all, and a very successful week for your program. Thank you.
Thank you so much, Professor Sen, for your kind introduction. Moving on, I now take this immense pleasure to invite our guest of honor, Professor K.K. Pant, Honorable Director, IIT Roorkee, to kindly impress us with your words of wisdom. Over to you, sir.
So, our guest, Dr. Soni from IMD, Head of the Department, Professor Sen, Dean Administration, Professor Arya, and the coordinator of the session, I think with whom you will interact more and more for next week, till next week rather, Professor Piyush, and the comparer of the show, both the comparer of the show, right? My dear faculty members for sitting on the dais, and young participants who have come all over the India, and other students, research scholars, and guests. Very good morning and very happy new year to all of you. I hope that new year will bring new heights of success in everyone's life and your family will remain healthy throughout the year and all over the coming years. The session, right, the which have been mentioned told me to me that the FORESEED, this is called, and very important in terms of what you call forecasting and early warning of extreme events and disaster, which is very important nowadays. Especially, as already Professor Arya and Professor Sen told about the history of IIT Roorkee. It's a 175 years old institute, and we have celebrated this just last year, 25th of November, our 175th year. Several conferences were held during that period. The most important thing that you look, the Devbhumi we call Uttarakhand as the Devbhumi, right? And it has the river Ganges, right, which flows all through the Himalaya. You must be aware about the temples, Badrinath, Kedarnath, right? So it has the heritage. But most of the time, right, because you are working in those areas of research which involves the climate change control, modeling, and then how to maintain the climate, then there are issues related to landslide. You know that lot of pressure have been made, right? When you look at the tourism, then roads have been built up, and how these roads have been built up, the right hills have been right the blasted partly, how the impact has to be given to the hills, and that creates lot of shocks on the right rocks. And gradually over the years, there may be a kind of but the issues, right? Because there are a lot of geological changes occur, and because of that, the areas become certain portions become weak, and then landslides and all these issues come. You must be reading the newspapers that Josimat, that is another right place in Uttarakhand, it has lot of issues related to shrinking. The news says that Josimat is shrinking. Why this is happening? You can tell all that, and you can find the solution to that. Most of the time, must have heard about landslides, right? And then one of the important problems which happens and to be addressed is what you call the glaciers, right? They are melting, right? Because of the global warming issues, right? And then again, the cloud busting. Nobody has found out, right, so far the solution for when the cloud busting will happen, why it is happening. A lot of thermodynamics modeling simulations are to be done on that area. Then the impact of these gases, right, which have the carbon dioxide into the environment, how carbon dioxide concentration, which has reached to a level of 412 ppm, and how does it affect the Uttarakhand area or any, right, when you talk about the tropical areas, right, how these climates, right, change, which is being monitored regularly. But what is the impact of these changes, like the gases, toxic gases, sulfur, SOx, NOx, COX? How does it affect the environment, and how does it make the right change in the pressure of the system, right? When you talk about the clouds, and then how the cloud busting occurs, right? We need to find out the solution of that. So this WRF model, I don't know to what extent it is helpful, but we need to work on these kind of models or similar models, right? Whether you talk in terms of weather research, right, and then forecasting. So it requires a lot of fundamentals first. So your thermodynamics should be very strong. You need to understand the mass balance. You need to understand heat balance. So in our regular fluid mechanics, sometimes we call it Navier-Stokes equation. I don't know how many of you heard, but it is something like momentum balance, energy balance, right, pressure balance, and then followed by the continuity equation. You find out the solution for these kind of things. So most of the time you do CFD for that, right, which is also one of the ways to understand what is happening in the local region. But for that, the most important thing is that data availability. So how many data are available? Because it's a 175-year-old institute, IIT Roorkee, we are talking, right? And if you want to collect the data, that why this cloud busting happens, in what regions it has happened, sometimes you talk in terms of Chamoli, sometimes you must have heard about the Mandi, Himachal area. So all these hill areas, they have a lot of issues related to cloud busting, right? Then the second is landslide. So it's a very frequent, and nowadays it has become much more frequent. Earlier, the frequency was not that much, right? Earthquakes are coming, right, and these are also coming very frequently. We need to find out a solution, right? First, how to identify, because we cannot, right, control them, because some of these are natural phenomena which happens, although these many are happening because of our own, right, because we have changed, right, our life systems in such a way that this system and the natural, we have disturbed our ecological system, right, we have disturbed our geological system. So now the things are happening at a faster rate. If we are by some models, right, when you talk about this, right, weather research and forecasting, these kind of mathematical models, numerical simulation, but followed by the case history, these are very important, because sometimes you have the models, you are putting right input, output, and getting some output, but how this black box which is inside the model, how these equations are simulated to our own interest, that's very important. And you guys under the masters and post guys, right, you are there to change those things, right? So sometimes we purchase the models and then put the input data and we see the output, what is the success rate. So reliability of that model is also very important. We need to find out the solution for those. So friends, my most important objective is that you should learn the black box of that model, right? You should identify how this, if you are giving some input, how the output is changing, and then what is the sensitivity of that data, right? And then put some the data which are already available in past. You see the Uttarakhand is much or more resemblance to Switzerland, right? So the data which are there in Switzerland, and if we have the data here, right, in our Uttarakhand region, and I'm just taking the example of Uttarakhand, but this should be taken to all over the country, right? So, because you know that floods are very common, right? And gradually you see the Chennai is getting more and more rain and getting more and more floods nowadays. Even the Bangalore got it. Earlier days, Bangalore and Chennai were not happening that much intensity of the rains, but now it is happening, right? Uttarakhand, every time, most of the time, right, in the month of May, June, there are the issues, right? Whether it is a cloud busting or some kind of say, landslide, right? It may be some kind of pressure on the, right, the tourism, because that is again another region, but we need to identify. So when you see that the new tools of the, right, the science and technology like deep learning, which is coming up, artificial intelligence, machine learning, this should also be, right, studied simultaneously. So WRF you are studying, that's very good, but simultaneously look at the other models and find out the solution for these kind of problems. And there are plenty of opportunities, because as Dr. Arya also said, we have earthquake, right, engineering department, and we have detect the sensor, right, which can detect the earthquake 45 seconds before. So we can now find out, right, if these kind of things can be developed, 45 seconds can be increased to 1 minute, or then further. The sensors are very important, right? So how these shock waves are coming, how these can be measured, at what rate, these are also important and need of the hour. So if we are able to work on these kind of, right, theoretical and experimental studies, as Dr. Arya said, we had, right, the earthquake engineering department, all kind of facilities available. Then disaster management department here, the center, not the department, the center, right, which is working hard jointly with other departments also, because it is the need of the hour to work as a multidisciplinary research. So research is nowadays multidisciplinary. So this center with connected with other departments, which is whether it is the water resource development, because flood is also very important here, right? And then these are some of the, right, natural cause, but also the quality of the water monitoring, control, environment monitoring, that is management of the environment, how the toxic gases concentration is increasing. So continuous monitoring of this, what you call climate change, and then, right, look at the, find out the models and the solutions, how to mitigate the concentration of carbon dioxide or other toxic gases in the environment, and how the weather change affect the concentration of these kind of, right, the gases, toxic gases. So friend, I will not come in between you and, right, the session. I know that you have a limited number of participants, and that is the advantage of this program, which SERB has called it the Karishala, right, on this, right, important area of the research, WRF modeling. And I'm sure that from today to, right, next Sunday, coming Sunday rather, you will be, right, learning many new things, and that you can transfer to your friends, right, when you go. Because exchange of knowledge is also very important. You interact with here also with our PhD students and master students and other students. Our semester just started today only. So you will find a huge, right, crowd in the campus from today onwards. And you interact with the people. The campus is very vibrant. You will love to visit the campus. So, and at the same time, learn the things, right, which the coordinator and the other experts will, right, give the knowledge. They will share the experiences. And with all these, I wish you all the best, right? Wish you, right, a very happy and comfortable stay in our campus. I hope the accommodation must have been comfortable and you are just having the good quality of food. So all these are also very important. So enjoy the, right, the campus life and also study well. So all the best. Thank you very much.
Thank you so much, sir. Indeed, it's our pleasure to witness your presence and to listen your delightful words. Thank you so much, sir.
Now, I would like to request Professor Sri Krishnan, Assistant Professor at the Center of Disaster Mitigation and Management, to come forward to present vote of thanks. Over to you, sir.
Respected dignitaries at the dais, Honorable Director Professor Pant, IIT Roorkee, Honorable Chief Guest Dr. V.K. Soni, Head Environment Monitoring and Research Center, India Meteorological Department. Thank you. Professor D.S. Arya, Dean Administration, IIT Roorkee, Professor Sumit Sen, Head Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, Professor Piyush Srivastava, Coordinator of the FORESEED event, Dr. A.K. Mitra, former Head, National Center for Medium Range Weather Forecasting, who will be joining us later in the day. Dear participants, students, FORESEED team members, and also joint faculties, Professor Diman and Professor Das, for your kind presence. All other faculty colleagues from sister departments of IIT Roorkee, a very good morning to you all. A vote of thanks is the monotonous, many times boring, yet courteous part of any inaugural or valedictory function. I am here to deliver the same on the invitation of Professor Piyush Srivastava. Let me begin by thanking the event coordinator, Professor Srivastava, for envisioning the importance of the training on the weather research and forecasting numerical model for disaster mitigation and management. All the 15 participants here know very well the importance of the training on the WRF model. We are very thankful to DST SERB for providing the funds to organize the FORESEED event. India has achieved excellency in the early warning of major meteorological hazards, if not all, but many. As everyone here knows well, thanks to the efforts of two institutions, that is the IMD and NCMRWF. Here we have to thank the invited guests from IMD, Dr. V.K. Soni, and from NCMRWF, Dr. A.K. Mitra, for agreeing to our request to deliver an invited lecture. I also thank Professor Ian Brooks from University of Leeds, UK, who will be delivering an invited lecture in the second half of the day. I sincerely thank Professor D.S. Arya, Dean Administration, IIT Roorkee, and Professor Sumit Sen, Head Center of Excellence in Disaster Mitigation and Management, for encouraging and supporting the event since the beginning. Our interactions with Dr. A.K. Mitra and also Dr. Mohapatra, Director General of Meteorology, IMD, stressed the necessity of establishing a landslide early warning system in India. On behalf of the landslide community, I sincerely thank the organizing committee of FORESEED for hosting specialized training sessions for landslide modeling and early warning systems, which is a need of the hour. We thank all the speakers of technical lectures for their time and valuable contribution in the coming week. We sincerely thank the student team for their tireless efforts in the pre-planning and organization of the event. Thanks also to the staffs of CoEDMM IIT Roorkee and also to the video and audio support team of IIT Roorkee as well as media support team of IIT Roorkee for their extended support. Thank you again everyone present here. Let us hope for more scientific vigor in 2023. Wish you all a very happy new year and pleasant stay here in the campus. Thank you very much.
Thank you so much, Professor Sri Krishnan. Ladies and gentlemen, now the high tea will be served outside. Kindly gather here after 40 minutes for the further keynote lecture series. Thank you all. Thank you, sir.
वो काम नहीं कर रही थी। उसके बिना काम नहीं चल रहा। अब स्टॉप कर। नहीं नहीं नहीं, एक मिनट। शेयर इन द स्क्रीन। नहीं हो रही है। एक काम कर सकते हैं, इसको डबल तो नहीं रखा, ओपन की फाइल। अच्छा अच्छा, हाँ स्टॉप कर दूं। एक मिनट, ओ बंद है अभी एक ही प्रेजेंटेशन चला है। हमको ठीक दिख रहा है यहाँ तो। ठीक है ठीक है अभी ठीक है।
This will be your quality possibly. Air quality. After that, the ministry they can sustain. कोई केसेस के लिए प्रेजेंट कर रहे हैं या आपको ओवर भी है और अभी के में आएगा बेसिकली अगर इसको रोकना पड़ता है तो एक रूला बनना बहुत सारे बोर्ड भी मॉडल करता थोड़ा सा काम कर दिया मॉडलिंग का भी सवाल है नहीं बहुत सिर्फ रेनफॉल से हाँ ये मसले Yeah, because it's a brother. Thank you. Thank you so much. दो मिनट लगे पार्ट ऐसा मत कर मैं 89 दे गया 92 के पास specifically after 1960 diploma किया civil engineering 60 that's the education my area is more into water sources I don't into my department I don't do this नहीं से तो नहीं actually subject of article training center IIT Asia department of psychology WMO का हम लोग के डिपार्टमेंट है तो विजन 5 हां विजन 2 अरे 2 Department of Psychology and NWA. These are the two themselves which are that's the law of next. बहुत अच्छा कुछ करना obviously on that they are putting a lot of projects. I am the I know I am the better than the second of this. Oh, the puppy boy. They lane is हाँ lane is so बहुत बड़ा problem है again वो है कि आप जैसे experience what the slide is not supported Yes, I have working on this. Like core hardcore modeling, this working. More specific projects like many of these are very often. Let's talk about the I don't know. Equality का GATM में GATM first एक उसमें कर रही है canisters में connect करते हैं तो उसमें उससे लगे बचा करते हैं that inlet से बाहर से किसी को कम्युनिकेट ये get set up of database yes. Today's birthday, so my father is asking, are you 44 or 45? Oh, अभी बात बताओ। मेरा तो एक का 20 है। I have a story for it. तो मेरा बेसिकली 2 जनवरी 95। रियल 2 जनवरी। 10th में मार्केट आया, वो 0 ऐड हो गया, तो फायदा ही हुआ है नुकसान नहीं। तो 2010 2010 हो अभी लोग 0 to 0 की जगह हाँ 0 to 0 1 वो मेरे फादर का बर्थडे है लेकिन वो एक्चुअल शायद नहीं हुआ पहले तो बर्थडे मालूम होता नहीं था जब टीचर जब एडमिशन करवाने जाते थे तो वो टीचर बनते थे तो वो शिफ्टिंग से 1 year 10 months अक्टूबर में हो गया वो पूरा पहले तो निकलते नहीं Online. So, ये थोड़ा ब्रेक नहीं मैं गुस्सा हूँ मुझे मत कहना बात तीन है ना तीन एडमिट कब जाता है
Welcome back, everyone. Now it's the time for the lecture series. The first lecture will be taken by our esteemed expert, Dr. V.K. Soni, Head Environment Monitoring and Research Center, India Meteorological Department, New Delhi. But before that, let me introduce him in a very short way. So, Dr. Vijay Kumar Soni obtained his MSc Physics degree from IIT Roorkee and PhD in Atmospheric Sciences from University of Pune. Currently, Dr. Soni is working as Head Environmental Monitoring and Research Center, IMD, New Delhi. He contributed significantly to establish aerosol monitoring network in India for measurement of aerosol optical properties and estimation of aerosol radioactive forcing. He was awarded Certificate of Merit in 2016 by Ministry of Earth Sciences for his outstanding scientific contribution in the field of atmospheric sciences. I would like to invite you, sir, to share your views on air quality monitoring system at IMD. Over to you, sir.
So good morning, and I'll be speaking on this air quality early warning system and air quality monitoring. So, students already, Professor Pant has explained and set the agenda of this workshop, and as well as your future scope of working in this field actually. And if you know that most of the weather phenomena are normally distributed. They show a Gaussian distribution, but as the temperature is rising, this distribution is getting disturbed, and we are experiencing more and more weather extremes. And it's really very difficult to forecast the extreme events, not only in India, but all over the globe. The one field that is lagging is the forecasting of extreme weather events. And similar thing also happen in air quality forecasting. We are able to forecast the uh, uh, air quality with fair accuracy, but we fail to forecast the whenever the extreme pollution events occur. So just few slides in the beginning are very basic in nature, just to explain you why air quality monitoring is important. And if you see here that this uh, a normal adult breathes about or you can calculate this very easily. Average breathing frequency in a healthy adult is about 12 to 18 breaths per minute, and average volume of one breath is half liter. So if you calculate this thing, you will find out that almost 14 kilogram of air we breathe every day in 24 hours. So you can imagine how important is to breathe the good air quality. And this is our ambient air quality standards for India. Indian standards are still very high as compared to what WHO prescribes. So you just see this PM10 and PM2.5. Let's not focus on other things here. So PM10 annual is 60 and 24 hours is 100, and PM2.5 40 to 60. You remember these things, because the figures I'll show you will really scare you when you see this observed air quality in India. And this is my division and EMRC, Environment Monitoring and Research Center of India Meteorological Department. So we are monitoring ozone, aerosols, climate research, environmental management. We provide a lot of inputs to air pollution control authorities in India, and then air quality forecasting, greenhouse gas monitoring, precipitation chemistry. We are monitoring this precipitation chemistry right from 1970s. So we have a very long series of wet deposition data in India. And then solar radiation, we contribute to a World Radiation Data Center from India. And so these are our networks for ozone, aerosol monitoring, black carbon aerosol monitoring, and precipitation chemistry. Ozone monitoring we started in, you will be amazed to know that the first ozone measurement started in India in 1928-29. When Dobson, who actually developed this spectrophotometer for total columnar ozone measurement, he himself came to India and took measurements over 1 year in Kodaikanal. Then in 1940, we acquired one Dobson spectrophotometer, but systematic measurements in India as well as all over the globe started from the International Geophysical Year 1956-57. So we have a very long series of ozone data. total columnar ozone, surface ozone, and vertical distribution of ozone. So we have 5 Dobson spectrophotometer working since 1950s. This instrument is still considered as the reference instrument. Now not available commercially, but this World Meteorological Organization is very much interested to keep these instruments alive. So they have given responsibility to Japan Meteorological Agency to maintain these instruments and refurbish them whenever some problem is there. So every 10 years we send these instruments to Japan and get it calibrated and refurbished. And surface ozone and vertical distribution ozone, we have a very good instrument center in IMD. So these 2 instruments were developed by India Meteorological Department and still in operation. And we have a network of perhaps IMD is the oldest organization to monitor the aerosols in India. So we started with the monitoring aerosol optical properties using the fire heliometer, and then moved to Wolf's sun photometer, and then sky radiometer. Now, sky radiometer is most advanced instrument to measure the aerosol optical properties. It can give you aerosol optical depth, single scattering albedo, asymmetry parameter, and then using some radiative transfer model, you can estimate the size distribution in a vertical column. And further, if the basic idea to establish this network is to improve the accuracy of estimation of radiative forcing. Generally, very few countries have actually observed optical properties of aerosols. The one most important property, aerosol optical depth, is being measured by so many institutions and so many countries, but not other parameters. So that introduces a lot of uncertainty in the estimation of radiative forcing. And then we have established this black carbon aerosol monitoring network in India, so 25 stations. And for scattering properties, network of 12 stations in India. And so only one aerosol parameter that is not available right now, but we are in process of establishing that vertical distribution of aerosols in the atmosphere. So very soon that will also be added up in this network. So DRDO has developed actually this aerosol LIDAR for India Meteorological Department, and we will establish this LIDAR network in India also. So the first will come up in Uttarakhand only, nearby. This one station is there, Rani Chauri in Chamba district of Uttarakhand. And precipitation chemistry and aerosol chemistry, we are monitoring it right from 1970s. And we have a background station, Rani Chauri. This is the station, which is 30-meter tower also, and all kind of. So we are monitoring here this GHGs, carbon dioxide, CH4, N2O, CO and S2O also. CO is not GHG, not a direct GHG, it's an indirect GHG generally we call. But very important to know whether there is some contamination from anthropogenic sources or not. And then water vapor, that is also a greenhouse gas. And we have to report the greenhouse gases in dry mole fraction. So you need to know the amount of water vapor also to know the dry mole fraction. And all other some of the other measurements include precipitation chemistry, solar radiation, micrometeorology, and ozone, SO2, NOx, aerosol optical properties, black carbon, and size segregated aerosol chemical composition. So PM 2.5, PM 10, and total suspended particulate matter composition also we calculate from here. And measurement of nanoparticles. So we can measure right from 10 nanometer onwards all particle count and distribution here. And this is another activity that is related to EMRC. Very recently we started and developing some city-specific, urban-specific models for giving the forecast for urban region. You know, urban area is slightly different than the other kind of areas. So first thing we did that to develop a very high resolution LULC for cities. So Delhi we have prepared extensive LULC almost with 24 categories and 10 meter resolution. So that is very much required. You cannot forecast the heat island unless you have a very good LULC, land use land cover. So when we introduced this one, then we saw a lot of improvement in weather forecasting as well as the, I'll explain you in coming slides. So right now this activity includes the current weather observations, current air quality observations as well as forecast, then radar, lightning, satellite images, all these things are available here. And weather warning of district, city-wise, nowcasting, and ultimately the general public is interested only in the bulletin actually. But those who are interested, they can look at other parameters also, and distribution, and many things will be available at a single page here. And this is, so we, in India, we have about 370 air quality monitoring stations. So we receive data from all these 370 air quality monitoring stations. And we assimilate this data into the models and develop this forecasting. So observations as well as the forecast we prepare for all Indian region, all India. And before moving further, this definition of air pollution or air quality. So you will come a lot of these ambient air quality, indoor air quality, but the definition of air pollution that I like very much, and you will find this definition in many textbooks, and this definition is given by Professor Vitthal Murthy from Vizag University and widely quoted in the textbooks here, and that is the presence in the atmosphere of one or more contaminants or combination of thereof in such concentrations and of such duration that are or may tend to be injurious to plant, animal, human kingdom, or may unreasonably interfere with comfortable enjoyment of life. It's a beautiful definition. And some other definition, dictionary, and you will find. But those are very basic kind of things. So what do we forecast actually? So we have a regional model at 10 kilometer resolution, and then urban or sub-regional 10 kilometer to 400 meter, then single site at 400 meter and less also we are moving. Then forecast scale needs to match local air quality scales. Actually, some big cities like Delhi have a large number of air quality monitoring stations, but other cities do not have that kind of dense monitoring network. So we in Delhi we have about 40 atmosphere this air quality monitoring station. So we provide the forecast for each location, and for Delhi we provide the forecast for each location, and for Delhi as a whole we pick up the concentration and then average it out and then give as a single value for Delhi. So main pollutants are PM10, PM2.5, then ozone, CO, SO2, NOx. SO2 is not a problem nowadays because source is very limited, but CO, ozone, we find a large number of times these are the dominant pollutant. But 99% of time this PM2.5 dominates in Delhi region, where anthropogenic contribution is much more as compared to other things. So if we can forecast the PM2.5 well, then air quality can be forecasted very well for Delhi region. Yeah. But of course, these particulate matter depends on all other atmospheric chemical composition. Then dust is a major problem in India, particularly in northwest India and during the summer months and monsoon months. And then after monsoon, this stubble burning or stubble fire is the major contributor. Summer also this fire contributes, but because of weather conditions, we don't feel like it is impacting, but really it impacts a lot during summer season also. So all the air pollution control authorities like CPCB and state pollution control boards, the Commission of Air Quality, they require this air quality forecast, and they have to take action in advance after seeing the forecast. Earlier, what they used to do when air quality gets into very poor category or severe category, then after that they used to start some action, and they don't know how long this episode will last. So with this kind of forecast available to them, they can plan well in advance, and when these restrictions they have to impose and when they have to withdraw the restrictions. So all these are very important and depend on the air quality forecast. And then media, public, industries, schools, they are using this forecast. And this generally for general public, this concentration, they may not be very comfortable with this. So this color coded air quality index is given. Of course, personally, I don't like this air quality index, which is developed by CPCB. This is the formula. This formula is taken from the Ott and Thom 1976 research paper, and then you are seeing this formula has some breakpoints. So breakpoint for PM10 they have adopted from US EPA, and PM2.5 from China. So that creates a lot of problem. It means your distribution is very much skewed towards PM2.5. So most of the time you will see air quality index because of the PM 2.5 only. So this needs review, and already we have asked the CPCB to review this air quality index and developed India specific, not from other countries, adapted from the countries. Basically, it depends on the what kind of health effects these pollutants will have. So now a lot of health and air quality research is available, and this needs to be reviewed. And these are the health impacts. So this is the distribution is available on our website, and this website you can have a look. There is a lot of information available for students and researchers. The website address is EWS Early Warning System.tropmed.res.in, and same it is available on the India Meteorological website mosam.imd.gov.in. And observations, you can download a app that is the Samir, and this has information all over the country, all these stations all over the country. And general public also is using this app whenever they see some kind of event, or some people are doing some illegal activities that is harming the atmosphere. They can click the picture and send to the CPCB, and they take action. They reach at that particular site and then take action. So in environment monitoring, we have all kind of measurements, ground-based, remote sensing, and these are the major air quality forecasting techniques. Simple empirical approaches, parametrical or statistical models, and advanced physically based approaches. So we have statistical models. Now, you know, all are fascinated with the AIML. So we have that kind of model also. And we have very advanced physical based approaches, models like CLM and WRF camera. So I'll briefly explain you those models here, and I'll give you overview, and my colleague will join you, and you can discuss with him. On 4th, I think he is coming, and so you can discuss more with him these models. So actually, how it initiated in 2010, government asked us to, when this Commonwealth Games were organized in Delhi, they asked us to start this air quality forecasting services. And that time there were not many air quality monitoring stations in India, particularly in Delhi. So we established a monitoring network in Delhi. So 10 stations were installed, and then we started with the CMAC initially, but then moved to WRF chemistry model. So this system that was developed during this was called the System for Air Quality Forecasting and Research, SAFAR. But this SAFAR was limited only to 4 cities: Delhi, Pune, Ahmedabad, and Mumbai. So right now we have this air quality early warning system, and this early warning system has 2 main air quality forecasting model. One is the 10 kilometer regional air quality forecast, 10 days in advance, 400 meter for, we dynamically downscale it to 400 meter for Delhi region and provide forecast for 3 days in advance. And air quality forecasting based on IMD CLM. This is a collaborative work with Finnish Meteorological Institute and IMD. So we adopted their model and customized it for Indian region. So this very recently we have improved the resolution to 3 kilometer, and the Commission of Air Quality wanted forecast for 4 days. So we have now 4 days in advance we are providing forecast using this CLM. And this Enfuser is a very high resolution model, and street level up to 30 meter we give forecast. So in experimental stage, but it is giving good results. So specifically, you can identify which are the hot spots within the city, and you can initiate action on those hot spots. And this is being expanded to all the non-attainment cities where air quality standards are not being met. So these are about 120 cities. So 65 cities we have introduced this system for air quality forecasting, and slowly we are increasing this number of cities in the system here. But only a biggest problem is the emission inventories for different cities. So as and when we get the emission inventories of cities, we keep on adding these cities in our network. So this is the web page looks like, and the front page is good enough for general public and even for control authorities. And those researchers and students, they should go into the website and see what kind of parameters we have. If time permits, then I'll directly show you the website here and introduce you to many parameters. Recently, we have established a very advanced observatory in IMD Delhi, Lodi Road, where we have all kind of measurements available online, including the chemical composition of aerosols, near real-time chemical composition, which is not available in any other institute in India. So we have the mass spectrometer, we have GHG monitoring, you name, and all that kind of parameter is being monitored. So as to real time, as to know the real time source apportionment of these air quality parameters. And this is on right side, this is the India Meteorological website, and we have these apps also, Mosam, and for lightning, Damini is the app, and for agriculture meteorology, we have Meghdut app that is being used by farmers mainly. And we send about we have almost 4.5 crore farmers registered with us, and daily the SMS is being sent to them for agriculture and meteorology forecasting. Means when they have to sow, when they have to use fertilizers, all this kind of information is being provided to farmers directly through SMS. So basically, this is the flow diagram of air quality early warning system. So we have in situ measurements, almost 370 stations, and then satellite-based monitoring, AOD, and fire counts. So these are the observations, and the weather forecast models we use is the GFS and WRF. So we couple this chemistry transport model with this weather forecast models, and then generate the air quality forecast for 3 days, 10 days, and 4 days now. And the visualization products, the animation of all these parameters, and then city specific and station specific plots, and then information is being disseminated through website as well as to authorities through a bulletin. And this is the model system for integrated modeling of atmospheric composition that is developed with the help of Finnish Meteorological Institute. So here you can see that we include almost all the observed parameters like the fires monitored through satellite, and they have this fire module IS4 fires. So this is being assimilated into the model, and then we have a very long coastline, almost 7,000 kilometer long coastline. So India is getting affected from the aerosols from sea. So that is also being taken care of. And then we have Thar Desert in the northwest India, and that is affected, and also the transported dust from the Arabian Peninsula is affecting the Indian region. Few slides I'll show you, and then only you will appreciate how big is the dust problem in India. So this data is being assimilated in the model, and then physiography, land use, forest mapping, ship data also is going into this model. Then bio VOC emission models, anthropogenic emissions data. CAMS is the latest emissions available from the CAMS. This is basically from ECMWF only. And so they have, EDGAR is a little older emissions. So CAMS is 2020, they have very recent emissions available to us. So, but we use both here. For EDGAR, actually, we are using some coarse mode and mineral fine anthropogenic particulate matter emissions from this model. Otherwise, all other emissions from the CAMS. Then Finnish Met Institute is running this Silem global boundary. So we are global model. So we are taking the boundary conditions from them and using it for this regional model. So, so this is how we are generating the forecast for Indian region. And these are aerosol processes and emissions on left side. You can, this presentation will be made available to you. You can have a look, and anytime we'll be very happy to receive any questions or any query from all of you. And generally we respond to the queries whenever any question, or if you are interested to work with us on these models, then you are welcome to do that. So these forecasts are available, and for you can select the cities. So 65 cities are available in this for Indian region, and we are preparing forecast for almost all the parameters, but we have capability to include more species in the forecast. Means including wet deposition, dry deposition, and many other species. Columnar ozone also, then columnar AOD also. Many other parameters we can include in this one. And this is the 30-meter very high resolution model. So it takes the output of coelom, and then many other geophysical parameters are fused into this model. So all kind of GIS, population density, traffic data, all goes into this fused with the this model, and this 30-meter resolution forecast is being generated for next 3 days. So this is being used in many countries, many big cities in different countries. So, but the accuracy is still being validated for this Delhi region. So, if we find that it is working well, preliminary estimate is that it provides very good estimation of air quality in cities. So only problem is the getting data like activity data. So in Finland, even the morning time you are cleaning the roads, that data also goes into the model. So they run their 10-meter resolution. But Helsinki in Finland is very well known for aerosol test bed or air quality test bed. So they have a very dense air quality monitoring and weather monitoring network in Helsinki. So you can just Google and see this Helsinki test bed, and you will find a lot of information about the Helsinki test bed. So a very good example of developing the modeling system for cities. And this is a very advanced WRF-CAM system for Indian region, actually for Southeast Asia, and then downscale to we basically Delhi gets most attention. So if Delhi is polluted, means whole India is polluted, or this problem exists in Delhi, it's all over the country. So this system was developed because SAFAR was not behaving very well for Delhi region. Then government asked us to develop another system for Delhi specific and Delhi region. So we initiated this early warning system, and that was mainly for the extreme events. Delhi, it happens that for a week together, this air quality is in severe category. It happened a lot many times here, and that time, and Supreme Court is monitoring Delhi air quality very closely. So, it becomes a problem when Supreme Court gives direction, and we have to act on these things. So here, aerosol optical depth is being assimilated. So we get the MODIS pass over Indian region twice. Two MODIS are there on board Aqua and Terra. So those who are not familiar with the AOD, AOD is basically the aerosol load in the columnar atmosphere from surface to top of the atmosphere, and it is a proxy for the surface particulate matter. There are many models available nowadays which can give the particulate matter PM2.5, PM10 based on the aerosol optical depth measurement. So we get two pass over India, and 6 UTC and 9 UTC that is being assimilated at 9 UTC. And surface PM2.5 also from all over the country. We have a dense network now, 370 stations. So that also goes into the model. And as I said earlier, that during October, November, major problem comes from the stubble burning. When the atmosphere is more stable, And when atmosphere is more stable and you get additional emissions from stubble fires, then the problem becomes very severe in not only in Delhi but all northwest India, whole Indo-Gangetic plain. And I'll give you all the examples of these, how stubble burning is impacting, and when you assimilate this data into the stubble, into the model, then how good becomes the forecast. Then EDGAR emission and MOES has developed Ministry of Earth Sciences, a 400-meter emission inventory for Delhi region. So that we are using, and some other institutions also developed this emission inventory. So that also now we are taking care, using them. So Terry has given us 1 kilometer resolution emission inventories for Delhi NCR. This was for Delhi region only. So that also we are using nowadays, and developed a DSS, decision support system, based on that. So and this system is driven by the forecast product produced by IITM GFS, and initial and boundary conditions at 12.5 kilometer grid resolution available every 3 hours. So my next speaker is from NCMRWF. So NCMRWF provides us the initial and boundary conditions from global models. Their job is to run the global models. So he is a very good expert. So interact with him on data assimilation and different kind of models. He's basically a modeler. I'm not a modeler actually. So this is the as I said, this the fire data from MODIS. MODIS provides fire data at 1 kilometer resolution. But now this Suomi NPP provides the fire data at 375 meter resolution. So that also now we are implementing into the model. And then MODIS provides this AOD that goes into the model, and air quality data that also goes into the model. Then meteorology is from IITM GFS model. So that also means this chemistry transport model is coupled with the GFS. And the LULC for then dynamical downscaling we are doing, and preparing forecast at 400 meter resolution over Delhi. So here comes the importance of this this LULC. Better is the LULC. Better you can forecast the temperature, and if you are able to forecast temperature very well, then the another important parameter that can be forecasted very well is the mixing height. Mixing height is the height up to which pollutants get mixed into the air. So earlier when we compared our observed mixing height with the model mixing height, then we found that we are overestimating mixing height. And if you are overestimating mixing height, then you will underestimate the concentration, surface concentration. So with the improvement of LULC, you improve the forecasting of concentration very well. And most of the fire actually takes place in Punjab region. So almost 74% is from Punjab region. Then Haryana is 12%, 12% also the adjoining Pakistan region. Then Rajasthan, J&K, other states are very small as compared to the Pakistan, Punjab, Haryana and Pakistan region. And on right side, you can see the total fire counts, and yeah, here you can see that if you assimilate these fire counts, then your forecast is very close to the observation. Here you can see that these fire events here in the green panel, you can see this increase in surface PM to 2.5. And when we assimilate this satellite data on crop fire, then we are able to predict this event very closely. So when you assimilate this fire counts, then we are able to produce the forecast very well. But unfortunately, the fire events you cannot forecast. Means you will not come to know that tomorrow this fire will take place at this region and these many fires will be there. So we developed our own system to forecast the fire counts. We have a climatology of fire counts available with us, and then generate some kind of probability forecast for probability for fire taking place in that region, and that we include. And once the fire observed we observe the fire counts. If fire happens in that particular grid box, then we remove that. Another fire will not happen during that season on that particular grid. So that way we are trying to predict the fire count, but still a lot of challenges are there, in particularly taking into account these fires. Other events you can very well take into account, but fire counts is really difficult. But still you can see the black one is the observation, and the blue one is without assimilating the fires, and red one is the fires. So when we assimilate these fire counts, fire data, then we are very close to the observed. And then another improvement came from this when we started assimilating the aerosol optical depth into the model. So we could very well simulate the observed PM 2.5 concentration when we started assimilating this one. So here you see the PM 2.5 accuracy increases. So observed here is the blue one, and then without assimilating is the black one, and with assimilation it is the red one. So again, when we are assimilating the AOD into the model, then we are close to the observation. And then comes the impact of assimilating the observed values. So here this black one is the observed concentration of PM 2.5, and when there is no assimilation, we are underestimating highly, and when we are assimilating the observations, then we are very close to the observed air quality. So every day at 9 a.m., this observed values are being assimilated into the models. The idea is that when you start your model well, then you then you will end up very well. So we are starting the model very close to the observed air quality, and with the considering that we'll end up very well by this assimilation. And again, there is a lot of uncertainty into the emissions that is developed by any institutions. If you compare, if you review all the emissions available to you, you will find a large difference in the models. And this emissions developed by Ministry of Earth Science SUFFER program, 400-meter resolution, that also sometimes we have to adjust in different seasons, because these emissions are developed through a survey in particular season. So this when students are available to you to do this kind of survey, and these emissions we developed in summer months when school colleges were holidays were there. So for 2 months we took observations in Delhi and surveyed all kind of pollution sources, including the traffic data junctions. And but still we have to adjust these emissions so that the observed air quality is close to the forecast values. Forecast and air quality values are observed values are close. And this is the impact of land use, land cover. So if you see this 1 kilometer LULC, then whole Delhi is covered into one category, the complete urban. But it is not so. Within Delhi also a lot of areas are there where vegetation is there, water bodies are there. So all these, if you segregate, then only you will be able to forecast the temperature, RH, and mixing height very well. So, so when we changed to 10 meter LULC, then we saw a lot of improvement in the temperature at 2 meter. Here you see this one, and then ultimate goal is to provide a better forecast for the mixing height. So with the introduction of better LULC, we are able to identify the heat islands within the city. So and the mixing height. So mixing height is very important parameter when you forecast the air quality. So with the introduction of 10 meter LULC, the forecast became really improved very well. So this is again that means impact of both assimilation of MODIS AOD as well as the observations. So when we improved, when we included both the things, then this observed as well as the forecast values are very close. And you see here that we are very well, we are able to capture the gradual increase, sudden increase, and sudden decrease of PM 2.5 levels. But here you see how the concentration is behaving. Means the PM 2.5 concentration can go up to 900 microgram per cubic meter. And what was the standard? That is 40 and 60. So almost how bad is the air quality and how it changes quickly in cities. That is the example here. So we failed to capture these peaks. So that is why I am saying that the extremes are still very difficult to capture. So WRF CAM also failed to capture, and CLM also failed to capture these peaks, extreme events. But we are able to capture the rise and decrease as well as the transition. So that is also very important. But extreme remains the challenge still. So in that was the hourly concentration, and here it is the daily concentration, and this is the first day forecast. So as your forecast days also increases, then this accuracy also decreases. The first day forecast will be more closer to the observed value, and then we'll keep on deviating from second day and third day like that. So both the things are very important here. 4 days forecast is important, and then short term a nowcast, you can say that within a day what kind of variations will be there. So all these things we have to include and then give forecast to air pollution control authorities. And these are the forecast evaluation skill score and for winter season, and you can see this false alarm ratio is 0.11, 0.09, 0.09 for unhealthy categories, means when your air quality is in poor category. And then probability of detection, CSI. So within poor range means unhealthy categories, we are forecasting very well. Then comes the very poor category. So your forecast also going a little bad actually during this when air quality is in this category. And severe category, again, we are having a problem. But still, these values are very good when you ask some modularly. So, but when you go to the control authorities, they want very specific forecast at 4 o'clock. What will be the concentration? You tell us, because CPCB tells that means their day ends at 4 p.m. before your office hours end. So they want to complete whatever action they have to take at 4 o'clock and then go home. So at 4 o'clock, they want us to give the exact forecast what will be, and that too within plus minus 10 unity. So, that becomes really a challenge for us here. We sometimes tell that it's not possible when meteorology is, we are not able to forecast the meteorology with greater accuracy. We are not able to forecast because most of the time, most means air quality largely depends on the meteorology. Emissions will remain more or less same in all the seasons except these external perturbations like fire emissions and some dusts. But otherwise, emissions will remain same. What is changing actually is the meteorology. So, better meteorology you could forecast, better will be the air quality forecast. So, this is all evaluation of forecast. But still, I can say that the forecast for at least 2 days forecast is very good. And many a times there are examples when the commission took steps and that really helped the people. And this is Diwali, and all festivals are little polluting. I'm sorry to say that, but it should not become a controversial. But Diwali, we pollute a lot, and despite of the restrictions imposed on firecrackers, still a lot of firecrackers burst in the city. And every time we enter into the severe category after Diwali, unless some rainfall is there next day of Diwali. Otherwise, most of the time we end up in the severe category. And unfortunately, Diwali falls in the October or November when meteorological conditions are most unfavorable. Immediately after monsoon withdraws, the air gets slowed down, direction changes to northwesterly in Delhi NCR region, and accumulation of pollutants take place. And because of all these conditions, together with the external emission, additional external emission, we end up in the severe category. And 2016 example is not here, but 2016 during Diwali, it happens that complete 6 days we were in the severe category, and it was difficult to breathe. Lot of health related problems occur. Health related admissions into the hospital because of this pollution increased dramatically in Delhi region. So this happens during this particular season. And of course, another addition is the stubble burning. So two additional emissions come during this season are emission from firecrackers as well as from the. So here you see this is the example of 2020. It reached in severe category, but we knew that next day it is going to rain, and it really helped in scavenging of pollutants. So we are providing one forecast for this ventilation index also. Ventilation index is the a product of mixing height and the wind boundary layer windy. So if ventilation index is more than 6,000, then your pollutants will get dispersed easily. But if it is less than that, then accumulation will happen. So and this is what happened recently. From October 2022 to December 31st, December 2022. You can see here this PM 2.5 here also went up to 600 microgram per cubic meter. So almost 10 times the limit we reach. And November is the most polluted because of meteorological conditions and the emissions from the stubble. So this year was a little better compared to last 4 years. 2020 was much better because of this COVID related restrictions. Otherwise, 2022 is much better for Delhi region. And this is the one very recent activity that we included this decision support system in our air quality early warning system. So this is Delhi, and around Delhi we took 19 districts, and which district is contributing to air quality in Delhi that we have tried to include in this one. So it's still developing, and this is the tracer-based emission decision support system. So we track the some tracer, we introduce some tracer in the model, and then take those tracers up to Delhi. And based on that, we are estimating the value. Certain traces like black carbon, carbon monoxide, you can introduce in the model artificially and then track those things. That is one way. Another easy way that I can tell you is that you want to measure the contribution of, estimate the contribution of particular species or emission source. Then once you run the model with that species, and then in another run, you remove that particular source and take the reference. That way you can, that is a very easy thing, but you have to run the model multiple times in that. That is very difficult because WRF-Chem is highly computationally expensive model and very difficult to run multiple times. So this tracer-based estimation is much better as compared to that. So we are trying to estimate the contribution of different sources within Delhi and from nearby region. So nearby region right now only means total we are able to tell, but not the species-wise or source-wise contribution. But for Delhi, within Delhi, because we have the emission inventories available to us, so we are able to tell specifically which source is contributing how much. Earlier, what used to happen that blanket ban means whenever air quality is reaching in severe category, there will be a blanket ban on activities within the Delhi and surrounding region. But now you can specifically take action that this source is contributing this much. If you remove this or improve this source, then this much improvement will be there. And again, if the wind direction is from northwest direction, you need not to take action on in Noida or like that, Ghaziabad. So that way, it is helping the authorities to take action, specific action, on improving the air quality. So if you control the, that also scenario you can create here, that 20% reduction in the sources, then how much improvement will be there in the air quality. And when that way we can, when we suggest this, that you now put these restrictions in Delhi region, then Commission takes action and put restrictions, and what kind of reduction is there, that is being estimated here. So observed and model after imposing the restrictions, this much improvement in the air quality is there. So that way we are trying to help the control authority. Hello, sir. So and you see now this impact of fire counts. So these red dots are basically the fires in Punjab, Haryana region, and you can see the layer of smoke over Indo-Gangetic plain. So there is a visible impact of this fire over Indo-Gangetic plain. And this is very common during October and November. And the another major problem is the dust sources. And one of the major source is the Thar desert and then Arabian Peninsula. and India is getting affected by both these sources. This is one example of during the 2012 this event. Two dust storms were observed over Arabian Peninsula, and those two dust storms merged together and took a shape of plume and moved towards the Indian region. And when it reached over Delhi, you can see that within a few hours, the concentration went almost 8 to 10 times of the background concentration. And through back trajectories, you can estimate how this dust is being impacting the Indian region. And when this dust reaches, not only the air quality gets bad, but it also influences the weather. Means the temperature, we saw the 5 to 6 degree drop in temperature when this dust storm approached over India. So, then in summer season, we have frequent dust storm from this Thar desert region, and you see that this dust storm originated over Thar desert, then moved over the Indo-Gangetic plain, and this is seen in the satellite pictures. This is a meteosat, and this is the MODIS. And again, we saw a significant rise in the PM10 particulate matter 10 micron. So we have many dust models. We have access to all these dust models that are being run under the sand and dust storm warnings of WMO. And China, Finnish, Korea, Japan, Hong Kong, ECMWF, ANSEP, and then Ensemble also. So all these models are available on this WMO Sand and SDS WAS site. And we have the not only the products, but we have access to the data also from this region. So this system provides you the observations, online observations you can see, and the forecast of all the models, and then ensemble of all these models. And we have our own model from NCMRWF, dust NCOM dust forecast model. So this provides the forecast for next 10 days, but it is a meteorology driven model only. It does not incorporate the chemistry into it. So we know the thresholds, at what wind speed, what kind of dust will be lofted in the atmosphere, and how it will travel with the meteorology. That is, so these are very simple models, dust models. Dust can be forecasted with WRF-CAM and this also, SILAM also. But these are fairly accurate models when dust only is considered. So this system provides, this NCMRWF NCOM dust model provides the surface dust concentration and dust aerosol optical depth also. So on right side you are seeing this meteogram is giving the 10 days dust concentration, dust AOD, wind and rainfall prediction. So again, this is very helpful to know the impact of dust. Of course, not much can be done when this natural dust is approaching over any region, but still some advice to the general public can be given. Those who are asthmatic or having some kind of problem, then they should take care when they are moving out. This was again a dust storm in January, very recently, January 2021. The season when you least expect the dust storm. And this dust, you can see that in Arabian Peninsula, a lot of dust generating convective activities are there. Yeah? And this dust moved over Indian region, and we could very well see this animation is not working, I think. Yeah. Otherwise, this satellite picture is showing how the dust moving, and we could exactly simulate this dust movement over Indian region. And these are some of the observations you can see. The impact of mixing height here, how important is to forecast the actual mixing height. So in different seasons, it has different variation. So mixing height is lowest during the winter season, and maximum in the summer season, pre-monsoon. So so in pre-monsoon, actually, there is not much impact of mixing height on the concentration, but on or other season there is a significant impact of, particularly during the post-monsoon season. You see, when mixing height is low, then how it is, we are having very high concentration. When it is high, then this concentration decreases. So I'll end up here, and these are the mail IDs, myself and my colleagues, Sanjay, Chinmay, and Anikender. These three scientists are working with us. And to anybody, you can write if you require any data or any help from us. And we'll certainly happy to help you with the data or any kind of this thing. And then two scientists work very closely to us, Sachin and Gaurav from Indian Institute of Tropical Meteorology in Pune. This institute is basically our IMD's institute for providing the research products on operational products after research to IMD, so that the service department can need not to engage themselves in more in research work, but do more operational kind of work. So both are very good modelers, Sachin and Gaurav. You can write to any one of us, and we'll be certainly responding to this your request. So if any question is there, then I'll be happy to answer. Yes. Yes. In any model, basically you can convection is basically a function of the surface temperature and vertical distribution of temperature. So all these models, WRF or any other weather forecasting model, will have this forecast for vertical distribution of temperature as well as surface temperature. So that way you can estimate the convection and of course the moisture also. So all these parameters, if you can forecast very well, then convection can be forecasted. Yeah. Different. Right. Mixing height is same for all the pollutants. Mixing height is generally estimated from the vertical profile of temperature. So there are different methods of estimating, different definition, different estimation methods. Like you plot the vertical distribution of temperature and draw a dry adiabat from surface. Wherever this dry adiabat will intersect with the actual profile, that will be your mixing height. That is one. And another is the inversion height and intensity of inversion also. Wherever your temperature should decrease vertically when you move up in the atmosphere, but at certain point, if it starts increasing, that is your inversion. So that is also sometimes can be taken as the mixing height. And then Reynolds number and Richardson number, these are also can be taken as the proxy of this mixing height or stability of atmosphere basically. No, vertical mixing. So advection, of course, advection will be means dispersion. Dispersion you means through advection only. Advection you means horizontal movement here. That is because of the change in wind speed. And without wind speed also there will be a diffusion. So, suppose calm atmosphere is there, then also diffusion will be there because of difference in the concentration. So thank you. So I'll hand over now Dr. Mitra.
Thank you so much, Dr. Soni. It was delightful to listen you, and indeed it was very informative session. Ladies and gentlemen, please put your hands together for our notable speaker. Now I request Professor Piyush Srivastav to honor our honorable speaker with a lovely memento. I request Dr. Soni to please come forward and receive it as a token of appreciation from us.
It's a really a proud moment for me actually. I have been graduated from this institution. I did my MSc and MPhil, MSc Physics and MPhil Instrumentation from IIT Roorkee. That time it was University of Roorkee. So I really profusely thank Professor Piyush who invited me, and really a proud moment for me.
Thank you so much, sir. Indeed, it's our pleasure to have you here. Ladies and gentlemen, we have with us our another notable guest, that is Dr. A.K. Mitra, former head, National Center for Medium Range Weather Forecasting. I request Professor Sen to please welcome him with a bouquet.
Now, I would like to request Dr. A.K. Mitra, former head, National Center for Medium Range Weather Forecasting, to kindly come to stage to share his views on prediction of severe weather from real-time modeling system.
Yes, sir.
Good morning. I'm very happy to be here and meet all the young researchers. And I understand you are early career scientists, and some of you are doing your PhDs or some of you have completed PhD. So I was looking at the syllabus and the goal of this training program or workshop. So what I tried to do, because I come from a modeling institute, modeling and data assimilation, and as introduced that I recently superannuated from National Center for Medium Range Weather Forecasting. So most of the things I'll be talking to you is about modeling and data assimilation. And one thing I want to introduce, which is very key now, something, a concept, seamless modeling system. So I'll be giving emphasis on that. And of course, I have more slides than I will try to finish in 45 or 50 minutes. Then I'm here today and tomorrow, so we can discuss whenever you have free time. So the idea is, in this talk, I will try to introduce all the aspects of seamless modeling system, or you can say the Earth system model. Almost all parts, some glance you will see, and we can discuss more depending on your interest and what you want to know and where you are working. And because I was working in the Ministry of Earth Sciences, Dr. Soni, who just talked, he's my colleague in IMD. So what we do is all real-time applications. All our model development studies, even any publication we do, they are meant for using in real time. So it's not for publishing paper or it's not very academic, but has a real time application. So all my examples I will give, either it is used in real time or is going to be used under development, something like that. So any modeling center across the globe, there are some 10, 12 major centers in the world. You might have heard the name of European Center, UK Met Office, NCEP USA, Japan Met Agency, Japan, Bureau of Meteorology Australia. Like that, there are global modeling and data assimilation center, which are, you can count maybe 10 to 12 in number. So actually, this is the goal of our NCOWF, but since I am no more in NCOWF, I dropped NCOWF, then I saw it's fitting very well to any major centers. So the aim of any major modeling center is to continuously develop models which will be used in for the National Weather Services, and many other applications should be developed. So one of the mandate we had is to develop this seamless prediction system. So I will have a separate slide on that. Then this model verification and diagnostic, they are very important part. I consider them as part of model development, because unless you know the errors in the model, you cannot improve upon them. So all this weather and climate prediction model, it has applications in almost all walks of life, and particularly India, with our growing economy and population and strategic interest. You will see all these sectors are very, very important, and this weather information and prediction is very crucial. So here comes the seamless prediction system. So you may be aware that there are multiple scales in the Earth system or in our climate system. So very shorter scale, few minutes, like boundary layer or turbulence. It goes through weather, then MJO or intra-seasonal to interannual. Then you have heard about El Nino, La Nina, then decadal, then climate change. So this is the multiple scale we have to deal with. And earlier what used to happen, and we need prediction for all the time scale, from very short scale to even longer scale, climate change. So recently the IPCC6 report has come, that's climate model outputs. So what was happening earlier, that in each modeling center, there were people, scientists, they were confined to one group. Somebody is working on a very shorter scale, a mesoscale modeling, which is severe weather up to 2 to 3 days.
or somebody is working in a medium range, a 10 days forecast, or then comes the intra-seasonal multi-week forecast or seasonal forecast. So there are different groups in the same center. So this was the problem across all centers in the world. And in last 1 decade, all the scientists, they realized there was one workshop in 2008 in UK, and it was called World Modeling Summit. And it was discussed that the barrier between weather and climate, this boundary. So there is actually no boundary, they are all continuous. So what we feel today is weather. If you take a long-term mean, it becomes climate. So there should not be any artificial boundary. So people were working in isolation in different scale, and so the science was not developing very fast. Then it was decided that we should come closer. The weather and climate boundaries, scientists should work closer, and we have to develop one model which can be used across scale. So that is the basis of seamless modeling system. And at this point, there is some skill in the intra-seasonal to seasonal. See, definitely your short-term weather prediction skill is good. You may be watching TV, and many of the cyclone or cold wave or heat wave, everything is predicted 10 days in advance. So short-term weather prediction has improved a lot. There are uncertainties, but it has improved. But a lot of uncertainties at this end, climate change. So there are climate models and huge money is spent. A big group of scientists, institutes are working here. But even the IPCC 6 report, if you see, for our region, South Asia and Indian monsoon, there is a lot of uncertainty because the models are not very fine-tuned for our situation. So now what is happening in last 10 years, people are working together, and there is a single model. All the centers are developing something called a seamless modeling system. So same model, dynamical core, you can use at very shorter scale and for weather, for intra-seasonal, intra-annual, and decadal prediction also, and even up to climate change. So fortunately, our Ministry of Earth Sciences, Government of India, around same time in 2008, we took a decision that we'll collaborate with a group of institutes who are going for the seamless prediction system. And it happened to be UK centered. UK, South Korea, Australia, and New Zealand, India is part of that. And we started working together from 2008. And people realized it late. Now even USA, they started 2-3 years back developing this seamless modeling system. And by 2024, they will be having a system which is called their own seamless modeling system, which will be used from very shorter scale to seasonal prediction. Only last week, somebody was visiting from NCEP USA to our center, and we had discussion. So they have reached up to the medium range parts. Even the short range prediction and the multi-week prediction and the seasonal prediction part they have not done because that needs ocean coupling. But the medium range part, seamless modeling part they have implemented. So there is some skill only in the intra-seasonal to seasonal. So if that can be perfected, so the tools, so there are adaptation tools. Suppose we give a prediction that monsoon is going to be dry and there will be drought and there will be shortage of food grain and water scarcity will be there. So people have to adapt. So when the modeling community is trying to make predictions very accurately, there are other departments and scientists who are trying to develop these adaptation tools, management tools, disaster management tools, so that if a forecast is given, which has some certainty and accuracy, then it can be used by managers, administrators, and policymakers for food and water and other lot of things are there. So the importance of even if there is not much skill now in the climate change prediction or the decadal predictability for our region, but there is very good skill in weather and intra-seasonal variability, which I will show. And so when the model development is going on, so another area is now being developed, developing application, what we can do with this model output. So that's a very important area. There are in a country like India, Let's say there are agriculture applications, water resources applications, dam management, so many things are there. So they also need a lot of engineering and science things which can be then transferred to policymakers and these administrators. So these are the scientifically, what are the advantages of a seamless modeling system? That it's more efficient. So I will leave a copy of this presentation so you can see. So by developing one system, the duplication will be avoided. So model development cycle is faster. That's what I was saying. And the understanding will be better because same model you will apply across scale, because we know when you apply a model, the error grows very quickly. At shorter scale, the error grows and it further grows and becomes that signal to noise, it becomes noise totally. It outperforms the signal. So if you know how the error is growing in a particular modeling system, then you can improve the model across scale. That is one of the advantage. Then once you have tested that model across scales, you are using the same model in mesoscale, at city scale, and for seasonal prediction, then you gradually become confident with using that model. And it plays a synergetic role also with the climate science, because what I showed here, that the far end of the same modeling application is the climate change. So this climate change is a big issue, you may be knowing, and it's a real problem. Many countries are having problem. And so developing good climate model which can predict decades and centuries in advance is very much required. And another very important thing is, some of you will become familiar that in all countries, there are process-oriented field campaigns. That means you arrange special observation campaigns to study a particular process. For example, let's say one part of India, Nor'westers, Kalbaisaki, eastern part of India. So they are more thunderstorm specific. So one can have special observation campaign to study the observation part of the thunderstorm. Then once you collect the observation, you can verify the model. There are many tuning parameters which are actually we are using without understanding much. So we can verify our model with those things and fine tune the model. So that is where a lot of field campaign data can be used. Actually, in India also, our government spends a lot of money for field campaign. For example, scientists from INCOIS go to Bay of Bengal, and there are joint Indo-US exercises. They go to Arabian Sea, Bay of Bengal, spend months and spend crores of rupees collecting air-sea interaction data. So that data can be used here to improve, fine-tune your model. So once you fine-tune your model, again, you can test it across scale. So that is one of the advantage. So at what rate these models are improving? So ECMWF is the lead center in the world. Of course, we are not very far behind, and that 3-4 centers, I will show you some score. We are almost there. But there is a notion that ECMWF is the best one. So recently we published a paper to show that our models are equally good. So because a lot of Indian government agencies are buying forecast from ECMWF by spending huge money. So we want to impress upon that don't spend so much money by buying from ECMWF. You can use our free forecast and for particularly the government agencies, and it is equally good. So that paper has come in Journal of Earth System Science. We intentionally send it to Indian journal because if we send it to international journal, we don't know if it may get rejected or it may take long time, because what we are showing that our modeling system in India, we have 2 global modeling systems. They are equally good, comparable to any UK or USA or even ECMWF. So I will email you a copy of that paper. It came last month only. So this is one of the measure for tropics. What we do, compute the root mean square error RMSE of tropical wind, and we compare with observation, radio sound, because radio sound is the actual observation. And if you see with time, the RMSE is decreasing, and it's taking a long time, 99 to 22. So the ECMWF standard is, they say, in 1 decade, by whatever science, technology has improved, if you put that into the modeling system, there is a 1-day benefit in skill improvement. So in 1 decade, in terms of supercomputing money and scientists and research and satellite, taking everything together, they gain 1 day of forecast skill in medium range. So that's why the modeling work is very progressing slowly, because any science, like any other science, it takes time. So you cannot expect things will change overnight. So this is a very slow process. That's where the research is very important. So all the academic institutes must work with the national weather services to do a lot of research, because it's a slow process. But we are improving continuously. And this is again another type of skill score. I'm showing wind verification, June, July, August, September, because monsoon is very complex and your prediction goes wrong in monsoon because a lot of convection. It becomes very complex during monsoon. So best time to evaluate your model is monsoon. So we took monsoon months and just top few models like ECMWF, UK Met Office, NSEP USA, and NCMWF. And you see, when you reach day 5, we are marginally poor, but we are almost there. You cannot see this RMSE of wind. They are comparable, I will say. So there is not much difference in terms of statistics. This is another kind of graph which shows how much improvement is happening in tropical cyclone forecasting. This is also published in 22. So if you see earlier, the prediction of cyclone was restricted up to 24-hour or 48-hour. But now also, if you compare, IMD is the best prediction because they do ensemble and they use many models and make the final forecast. So if you see ECMWF, NSEP USA, and IMD's GFS, which is jointly developed with IIT Pune and UK Met Office and our NCMWF. So you can see that over the years during 2015 to 19, the new generation of models are doing better. So again, when it comes to severe weather like cyclone, it's improving. So one of the very important thing is, of course, this today's talks, Dr. Soni's and my talks are like, it's telling what's the final effect. And other lectures are coming up. I saw this WRF and fundamental of modeling is coming up. So what I'm showing the last final result. So you can better observe during the WRF lectures. So to initialize the model, there is something called data assimilation. So you need a lot of data. And unless you have good amount of data, you will not be able to initialize the model. And your forecast will be not so good, even if you have a very good modeling system. So we continuously monitor how much data we receive. We compare again with ECMWF. So this is a routine thing in our website. You can see monthly the reportings are there. And you see over the years how much data has increased in terms of GB. So earlier it was nothing, like less than a GB in 2008. But a lot of satellite and radar data which is available. So the question is how to make use of the satellite data using the data assimilation. So this data assimilation and modeling, they are both equally important and they are linked together. So now a huge amount of satellite data is coming, and luckily India, we have ISRO, and ISRO also is a very good organization which develops sensor, launches its own satellite. Only recently, last month, the OceanSat was launched. So OceanSat is very useful. It has scatterometer surface winds. So there are many such aspects of how to use satellite data. Thousands and thousands of channels are there. And how to use satellite data, that itself is a specialty. How to derive geophysical parameter from satellites, how to do the quality control. After you do the quality control, then how it can be used in the model. And then how to assimilate it. There are a lot of things there. And next comes the supercomputer. See, we have reached a stage we are using very high resolution global model like 12-kilometer global model. Regional models are 4 kilometer, and ensemble forecasting. I will show you ensemble. So you need lot of computing power. So unless we have big computers in terms of petaflop sustained capacity, you cannot do anything. So currently what we have is this 2.8 petaflop in our center, and in Pune there is something like 6 to 8 petaflop. So MOES has total around 10 petaflop of HPC, and that's why we are able to do all this thing, and all our models are equally good compared to any other centers. And now the procurement is going on in ministry. So we are expecting by this year, end of this year, InsurWF will have around 10 to 12 petaflop, and MOES overall will have around 20 petaflop of computer. Then at the end of my talk, I will show what we have tested and we are not able to implement because of this lack of HPC, and where ECMWF has gone. And we have tested those things, similar thing, but we are not able to implement. So there are various applications of this model. So one of the main user is IMD, and apart from IMD, there are many users like INCOES for making ocean forecast. They need weather forecast. So down across like cascading effect. So this slide I like very much. See, you might have heard about all women Navy officers going around the globe, Tarini. And we are able to provide continuously forecast, and they appreciated the forecast. So this is the kind of application that at a location and dynamically when things are moving, similar things are there in this army, etc. And now there is a huge increase demand in the wind energy. So there are different rules in the wind energy sector. They have to give very good prediction of how much wind energy they are going to produce. So unless they are able to give, because the energy trading has started, so they need all this thing. And like that, there are many other users. These are some of the few I have. So mainly you see disaster management. One is Power Corporation of India. See, they are running emergency response warning system that if some accident happens in this nuclear energy centers, what will happen? What will the nuclear material, where it will go? So they are running this kind of air quality or disaster prediction systems where they need this wind forecast. So, so we are providing them this wind forecast, and there are a lot of hydrological application. Of course, we share our all model data with IMD, and IMD distributes it to Central Water Commission. But there are many users who are coming directly to us also. So National Hydrological Project. So all water application you see, Bakrabi's, Krishna, Bhima Basin, they use rainfall prediction. So I was talking about this. You see, the wind energy companies, they need to predict 7 days in advance. They are demanding 1 month in advance. They want what will be the wind condition, and they want to make an estimate how much wind wind energy will be produced. So all these companies, they are Indian companies. Many of them are international companies. Like this is an American company, and Adani news you might have heard, they are becoming #1 now in wind energy. So we are giving them everything free, but we'll be charging them because in ministry the pricing policy, they are taking a lot of time. There is a committee which is working on how much to charge them. So as it happens in government, it's taking longer time. But we are giving them free, and we are getting very good feedback. See, they have all wind turbines, wind energy turbines, and they are giving us feedback that how good is our forecast, where we are failing. And that is very important for this model development. And that is, we said that you don't pass on this forecast to third party free, and you give us feedback. And so their number is going on increasing day by day. And of course, I think this year we'll start charging them. And we have promised that we'll charge 1/10 of ECMWF, because ECMWF people are addicted. They're paying huge money, including ISRO is paying huge money to ECMWF. So we are impressing upon everybody, government agency, that it will take from us. Of course, private companies will be charging because the government policy is now they are asking us to generate our own money, buy computers. So gradually we have to start charging also. And a lot of state disaster management department. Each state has their own disaster management unit. So one by one, both IMD and NCOWF, we are interacting and collaborating with them and how to make use of this model output for the day-to-day disaster management. And it was, I think if you get a chance, you interact with Karnataka State Disaster Management Authority, they are doing very good. And of course, Telangana and Andhra Pradesh, one by one, Odisha is also doing very good. But they are really very serious and they are using this forecast very intelligently. And they are benefiting, their state people are happy. I saw Karnataka, I spent some time there. So again, there is a huge demand. There is National Disaster Management Authority, but each state has their own disaster management authority. So all this model output will be very useful. Whatever you learn, either it is mesoscale model or country scale model or global model or seasonal forecast. So it has a huge application everywhere. Now coming to the modeling system, again, what I will be showing is like a glimpse, and you can discuss with me today or tomorrow. I'm here. And so I will just focus on what we have. In India, only NCOWF has the global data assimilation system. So we maintain, there are two modeling systems in India, NSEP GFS, USA based this model, IMD GFS, and they have also WRF, HWRF for cyclone, etc. So all the data assimilation for that is done in NCOWF. So what is used is a global 4D ensemble variational assimilation, and you can look for something called GSI. So GSI is a community in USA, a global statistical software that is compatible to both GFS and WRF. So when you learn a lot of WRF here, equally important is to be gradually familiar with the GSI system. But what NCOWF is doing with Met Office, there is a consortium, it's not Met Office, UK Met Office, Bureau of Meteorology Australia, NIWA New Zealand, and Korean Met Agency, and our NCOWF. And Singapore recently joined that consortium. So there are 8 countries we are together. So anything which is developed like in data assimilation or modeling, every 6 months there is an upgrade. And by having the partnership agreement, we have the right to access all those things. So we contribute to the development and we also get the latest system from there. And that is how we are able to catch up with other centers. It's not very easy because in India we have very limited scientists. If you count how many modeling data assimilation people are there, you can count maybe hardly 15 to 20 or maximum 25, 30 who are practicing. So it's very difficult. Like in the UK Met Office, they have at least 1,000 scientists. Out of 1,500 may be working in assimilation and modeling. In NSEP, huge community, all the universities they work. So all the input comes from the university and the operational activity happens in NSEP USA. So big communities there. In India, we don't have, but luckily due to this collaboration consortium kind of setup, we are able to absorb the technology. And frankly, we are not able to contribute that much back to the system. So we are receiving more than what we are contributing, but we are also contributing. If you see to our website, the number of publication, even I said writing a paper on skill of a model is very important. See, for example, we have local knowledge here for monsoon. So we have seen international people from USA, Japan, or UK. They want to learn about monsoon, at least the observation part, what is important from us. So once they interact and learn details of monsoon, then they take care of developing the model. So that way we are also participating and contributing in developing the model for monsoon, for tropics. So we have a global data assimilation system, which is hybrid 4D VAR. Then we have a regional 4D data assimilation, 4 kilometer. I will show you some result out of that. And we have a land surface data assimilation system, which is extended Kalman filter based. So it can assimilate many things, but we are assimilating only soil moisture. And in last 2 years, we have implemented the ocean data assimilation system, because you will see in my coming up slides that we have a R system now. Yeah, in the R system, both this is for taking care of the atmosphere, and this is for the land, this is for the ocean and sea ice. But now there is something again called weakly coupled data assimilation. That means as a whole system, it is can be a whole Earth system can be used as a simulation system, and we are working on that jointly, and we have tested it, and we will be implementing that soon. So I will show you some of the results from this. So this is a simulation. So all kind of this is one of our very important job. As soon as any new satellite data comes, luckily many of the satellite data are being shared internationally, but gradually it's becoming commercial. So we have to do some kind of intelligence spying, who is using what. And now I think we are entering into an era that people are launching private satellites, they're investing, and we have to start buying satellite data. So it's again a very interesting, challenging time. Because the government is asking us to make money, so we have to make profit by selling this forecast, and also we can invest in this satellite data. See that one company I was showing, tomorrow.io, it's an American company, it has a Bangalore office. They are launching some micro satellites. That is just one example I am telling. In collaborating with NASA and JPL, and they are offering that it's like a precipitation radar data. So they are like, they wanted our forecast free of cost. So we said we cannot give free, but we are giving them temporarily free. Then they are battering that we will give you satellite data, then you give your forecast. So that's the kind of thing. We are in an interface, things are changing. So earlier we used to get free data from ISRO. Now in India also things are changing. Even ISRO will be charging us. So we are paying now for OceanSat 500 crores. Earlier it was free. So we have to also charge, like we have the option whether to take from ISRO or we can take it from outside. Anyway, so these are currently all kind of satellite data which we use, and their number is growing. And this is again a continuous job, because a satellite's life is 5 to 7 years or 8 years. So the sensors will change, the channels will change. When the new satellite is coming, you have to develop the algorithm to assimilate them. So this is totally a using satellite data, radar data, each are different specializations. So when you, some of you who are trying to pursue PhD, these are all one area of work, like working with radar. Indian radar data is one area. One particular satellite assimilation is one PhD thesis. This is a typical example of what happens in real time, that all the observation I showed, it comes to IMD, there is a regional telecommunication hub. But I showed one of the plot that through this regional telecommunication hub, which is a part of WMO UN organization. So number of data coming from that is remaining stagnant, but number of data from satellite has increased manifold. So now we have bilateral relation with NESDIS, UMETSAT, and many other organizations. So that is the new trend. So their numbers are much more. So then it goes to quality control, then data assimilation, then it goes to all modeling, then users. So this is a typical, any modeling center, operational real time, you go round the clock, this is happening 24/7. These are some of the examples that what kind of observation you can see. So these are surface observations. So in modeling, surface observations are useful. We use only surface pressure in the model, assimilating that, and 10-meter wind. But rest of the observations are used for validating the model, not for, it's not an input to the model. So their number is good. Though there are gaps in the oceanic area, but their numbers are good. But this is really very pathetic. These are radio sound, we call it. It gives upper air temperature and moisture. So unless you have atmosphere up to 80 kilometers, let's say, you have, because to run the model and to give a forecast, you need 3D information of wind, temperature, moisture, and surface pressure. You see, very poor. You are getting only over USA, Europe, and China, and India, Australia. Africa, there is nothing. This southwest part, Gulf countries, there is nothing. And South America, there is hardly anything. So even if the models are very good, unless you initialize your model temperature, moisture, you cannot expect a good forecast. Now, for example, let's say over India, North India, you are having cold wave, let's say. And, in winter, these westerly waves come. So if you go up in the sky 1.5 kilometer, 5 kilometer, or 8 or 10 kilometers, these westerly winds are coming. And they bring moisture, temperature, everything is adapted from there. So in your data assimilation system, the global data assimilation system, it's not having any information here. So your model initialization for the temperature and moisture, even if your technique is good, computer is good, model is good, but lack of data is a serious thing. So in North India, you have something called western disturbance. I think 2 days back, you had snowfall in mountains and that some impact, some mild rain we got in this area also. So those western disturbances, its predictability is much more than monsoon. Actually, it can be tracked 10 days in advance, 15 days in advance, if your observations are perfect. Like in USA, you see these radio sounds, they have other thing, profiler also. So if a wave is coming from west to east, they can predict very well. These westerly waves, I'm not talking about tropical system. In tropical, they are equally bad. But in spite of that, in news, you might have seen what happened last week in USA. Something, bomb storm or something happened. And in Buffalo here, some 40, 50 people died. Forecast was good, but again, emergency response, disaster management plan, and people are not taking holidays, so people were traveling by car. As it happens in India, in Mumbai, heavy rain, people sit in their car and die. Same thing happened there. So anyway, coming back, that see, whole of Africa, there is no observation. Then Iran, Iraq, that area is always war and something terrorism war is going on there, and no observation there. It's happening for decades. And our Indian observations are good now. 10, 20 years back, ECMW pointed out that our observations were not good, but in last 10, 15 years, we have improved. We are buying good quality of observation. IMD has invested. So at one time, I think it was 35 in number, but there are many issues. So anyway, these observations are very important. So this is radio sound, how the distribution you see. This is aircraft observation. So any commercial aircraft we travel, it also collects data and it also communicates. So in India, the number of aircraft observations are less. Not that the aircrafts are not equipped or they are not taking observation, but again, the administrative procedure. There are so many agencies involved, Airport Authority, Director General of Civil Aviation, and so finally, actually, it's being now taken up at Prime Minister's level. So both IMD and CMWF, we are working on this. Hopefully, it will improve. But you see over USA how much observation they have from aircraft, over Europe also. So this has to improve. So only having a model or good estimation system cannot help. And luckily, we have good satellite data over ocean. See, in earlier plots, you cannot do much over ocean. So there is a lot of satellites. So these are like scatterometer wind. SCATSAT 1 was our, then ASCAT AB. So you just let me know when I have to stop. We can take a break, and because I have more slides I want to cover. Maybe after lunch also, few slides I can continue. Or what is the time now? So till what time I can? 1:20, okay. So I'll try to finish by 1:20. So basically, as I was saying, I'll go through slides and it's going to give you an idea overall glimpse of what is happening. Then you come back to me for further discussion. So this satellite data, what I was saying, again, I am showing all these plots. You can go to our website. There is a weekly monitoring report. PDF is available and they are freely available. You can download and see how much data we are getting. Yeah, there are different type of processed radiance data we are getting. This is a very important, interesting thing. GPS radio occultation data. Actually, it was meant for GPS purpose, global positioning system. But very good temperature moisture data is coming out of this. And now India government, our Panchayati Raj ministry is spending huge money for some different application. They want exact position of panchayat, etc., assets, land, etc. But as a byproduct, we will be getting this data. So this is very useful, has a very good impact on NWP. It gives a lot of temperature, moisture, vertical profiles. And these are the geostationary satellite winds, all different type of geostationary satellite India has INSAT, and all countries have different geostationary. They are freely exchangeable and available to us. This is a big asset. So but it gives only low level wind, mid level and high level. It will not give you full profile of wind, but this is very useful. So all the satellite names you can see and different channels, infrared, visible and water vapor. 3 channels, these winds are available. Yeah, they are again same type of thing. I will skip all this thing. Yeah, the same wind is available for polar region also. This polar forecast also is very important. We need equally important all ocean and atmospheric data there. So these satellites, polar orbiting satellites are giving wind data there. Yeah, these are radiance data which gives temperature, moisture information. So at any time there are 3 to 4 satellites, and they are actually launched by Europe or USA kind of community thing, and we get this data freely. So all these channel names like HIRS, so they are all they are from NOAA and METOP, the name of the satellites, and they are freely available to us, fortunately, to the world community. And this is very useful for defining temperature, moisture in 3 dimensional. So the nowadays, earlier we used to assimilate the profile data, but now the radiance itself is assimilated. So radiance assimilation in last 10 years is a new topic. What are the benefit of direct radiance assimilation? Clear sky radiance, IRC data. Again, scatterometer. So that day our SCATSAT Indian data was, due to some problem, was missing. But they are very useful. This Indian radar data which IMD is adding, and finally it will be reaching 65 to 70 in number. They are very useful for this WRF mesoscale assimilation system. And we have developed a very interesting tool. It is called FSOI. What is the impact of observation on the forecast? So you can see these different type of observations, and these are the impact. So there are published paper I can send you. So for 3 years it shows in 3 different colors, because this observation is a huge cost, either satellite or this surface observation. So before you invest, you have to make a study, that something called observation system simulation experiment. That is also a very interesting area of data assimilation. So you can see which observing system is having how much impact. See, for example, our INSAT 3D, our own satellite, but the impact is very less. It has other applications, but the maximum impact, like ETOPS, what I was showing, the radiance assimilation of temperature and moisture, this NOAA 3 satellites and METOP satellite. And aircraft, you see, relatively it has a very good GPS radio occultation, spectrometer wind, you see. This is the new ELUS wind. It's a very new satellite. Yeah, so this is a very useful tool. It can tell you before you launch, there is something called observation system simulation experiment, and you can decide that how much money you want to spend, what benefit you will get in any observing system. See, for example, buoy, ship data. So we cannot tell that it is so negligible, so let's drop it. It has other benefits. For example, all the satellite data, they are benchmarked against the SIP and buoy and radio sound. So we cannot tell that we will drop them. So relatively, but this tool is available. So this, we work very closely with ISRO. So for example, now they are launching some new sensors. So they are working with us to see the impact before it's launched. These are some of the examples. So I will move very fast because so any new satellite data comes, we do experiments that whether it has an impact, positive impact, or it should not be detrimental. It should not spoil the forecast. Then we put it into operation. So there are many such examples. This ELUS one type of satellite, it gives one type of wind. And we are one of the first, along with ECMWF, to put it into our modeling system, assimilation system. So these are some of the papers you can see. So this is ELUS wind impact. It had a marginal positive impact. Similarly, the scatterometer wind. So there are two SCAT A, B, and scatterometer 1, our Indian. So we have seen, we know it is good, but we have to document it because, you know, we have to show to ISRO, etc. that, and you also get paper, right? Paper that we know it is having an impact, but you diagnose and write a paper that it's having an impact. So any satellite data you can study and write very good reports. That's what the satellite data originator, the who are spending money like ISRO, you might said, they also want these papers. So this is the regional data assimilation system. We have 4D wire assimilation system. So it mainly assimilate all those data which is used in the global model, but additional is these two things. Indian DWR radar, radial wind, and reflectivity. So all this severe weather is supposed to be captured by this, and this is operational on our website. The products you can see the regional 4 kilometer. We have ensemble also, and very interesting thing is coming up. Again, you can see the impact of different scatterometer itself among scatterometer which is having impact how much. This is a particular study we did for a cyclone, Nivar. Again, I will skip this thing. So you can take up this type of study that by using only satellite, don't use satellite, what is the, how much benefit you get. So this is the real observation. When you use satellite, it's slightly closer. And at the landfall time, it's hardly any, makes any difference, but that's what is the impact. Yeah, so this is a new thing. Many of you might like to start working on this. It is called a high resolution rapid refresh because IMD is going to have so much these radars, 65, and radars give observations every 15 minutes. And what you can do, what I was showing data assimilation, they're done usually every 6 hours. So here you can do very high resolution model. It can be any model. So we have developed both WRF and UM. This example is from UM. And IMD, I think with ISRO also has developed one WRF 3 or 4 kilometer rapid refresh. So there are 3 systems in India, but they are in very early stage. For example, this system is not operational. So what we are doing, we have divided because our computer is limited. We are not able to run a 1.5 kilometer model for pan India. So we have divided into region, and there are regions like in pre-monsoon thunderstorm, you can run this model. In winter monsoon, you can run this one, peninsular India. So it's mainly for experimentation, but this is a new thing. So what is the difference is instead of assimilating every 6 hour, it will assimilate every half an hour. So it depends. Now there is a challenge for the data provider. See, radars are there, they have to be operational, all the generator, batteries, everything has to work. They have to communicate the data to our center or NWP center in real time. We have to get it within, actually we are getting now in 2 hours. So there is a lag going on. That is with all center in US also because it takes some time. But any severe weather which is developing, cyclone, thunderstorm, so you can very rapidly, in a refreshing way, update the initial condition and give a forecast. So it will give forecast up to 12 hour to 18 hour. This meant for severe weather only. It's called a rapid. So all countries are now going for this, including USA. They are developing their own, whatever is their model, the corresponding rapid refresh system. So this is a new thing. Soil moisture data assimilation is a big area. So like atmospheric model, you have a land model and you can go up to, you see soil layers up to 200 centimeters, 2 meters you can go. So this data, subsurface data of soil, now recently IMD has put agromet observations, which takes subsurface observations. So they will all can be assimilated, and you need a very good, well-defined soil moisture, soil temperature to make a good prediction. So earlier we are neglecting this. We knew it is important, but there was no means to do that. Data was not there. So now currently we are having for both global and regional land surface data assimilation system. It is very good for hydrology. It's actually a surface hydrological model also. It will give you surface runoff, everything, you name anything. And but it is an input and it is interacting with the model, atmospheric model or the ocean model. Again, they are published paper that how soil moisture initialization is helping monsoon prediction. And we have produced a very good data set. This, I think all the students can note this. It's called IMDA. So we have produced, using this regional data assimilation system, a 40 years reanalysis, 1979 to 2020. But people got used to it and they're demanding we are not able to do it in real time. But with the different chunks we are doing, up to 22 it's done, and the data you can download from here. And earlier we were using NSAP and European reanalysis, but now we have our own very high resolution 12 column, and there are papers related to that. That before using it, whether it's good or bad, it is equally good, or I will say it's better than any other reanalysis. But it's only for extended Indian domain. So this is very good for research and many applications. Yeah, now coming to the seamless modeling system. So I have shown you the models, but what we have implemented in India, in our center, same dynamical core, like Pius will tell you about WRF, it has a dynamical core. But same dynamical core, whatever we are using in the UM, it can be configured for Delhi. For Delhi fog prediction, it is used in winter, and it makes forecast for Delhi airport, and IMD uses this forecast. So you see the smallest scale is 330-meter grid. It is configured over Delhi. And you see 1.5 kilometer for India, 4 kilometer, 12 kilometer, then go to coupled model, the same dynamical core. It can be configured, both atmosphere, ocean, land. That's the beauty of a seamless model. Yeah, so these are the different configuration of the model. So when we couple it, we are running daily 2 weeks forecast. It gives ocean forecast, sea ice forecast for the polar region. It's a coupled model, so it's sea ice, ocean, everything it will give. Then once a week, we are running up to 4 weeks. It gives you extended range multi-week forecast. I will show you some example. And once a month, we are running it for making a seasonal forecast. So starting from very small scale, 300 meter to seasonal prediction, it is doing. So it can cater to all very severe weather to everything, the Kerala rain, etc. These are some of the examples. The Kerala is an extreme rainfall case. So what I want to show that the observation is here. See, the global model was giving 5 days in advance some hint of that system, but not so intensely. But when you use a regional model, because the 4 kilometer, so the severe weather is captured better. Same thing, this Uttarakhand case. So global model was capturing well, actually in 5 days in advance, but in regional model, it becomes much more better. And we do every season after the monsoon is over, what is the skill of the model? It's very useful for model development. So you can go to our website, each monsoon year, the skill you can see. And the skill of the model is also available in the internet and compared with other model. So you can see where we stand in real time. And for hydrological application also, we verify the model because the moment you come to some smaller scale, your skill drops. So whether you can use it in some basin, you cannot use it. So the hydrological central water commission, they need this information. So we verify at basin scale also. This is one of the example of the 330-meter Delhi model. We recently did some improvement. How to this some module called Moruses. That means the urban morphology data we improved, and it's predicting better. So that's published in a good journal. I can email that. Now coming to ensemble prediction system. See, until now I was talking about the importance of model, data, everything is so important. But in spite of doing so many things, because of the uncertainty, I showed you that observations are not enough. Model have uncertainty. So you have uncertainty in prediction. So if your initial condition uncertainty is here, the model spreadsheet. So finally, this is one new thing in India. We have implemented a very high resolution ensemble prediction system. Earlier, we are giving one forecast, deterministic forecast, we call it. And people are used to deterministic forecast. But we implemented it in European and other countries, they implemented 20 years back. But because we got bigger computer and all this infrastructure, we did it. But now we have the highest resolution ensemble prediction system. But unfortunately, it has to be used. Not many people are using. People want a single forecast कि आज बारिश होगा कि नहीं मेरे घर के ऊपर बता दो. But it cannot be. The science says there is so much uncertainty. So that means you need prediction, and you also, along with the prediction, you want the probability. What is the probability that it will happen by this many percentage? So the Western world business people, they are using it. One small example, I met somebody like ECMW gives the forecast in Europe. If you have gone, if it's a sunny weather, they will put tables in the footpath for restaurant taking food outside in the sun. And the business grows like anything. They make huge profit. So if you can predict that it is a cloudy, bad weather day or a clear sunny day, even the restaurant people are looking for that information and they want the probability. What is the probability that it will be sunny? If you tell it is 70% chance that it will be clear, 30% it will be raining, then they will invest accordingly. How much money to put, how much. So it is a small example. In every business now this is there because people are doing risk management. So if you want to take some risk, how much resources you are ready to spend. So people are demanding now, business people are asking that don't give deterministic, you give us the probabilistic forecast and what is the percentage that this is going to happen. So if you see other countries, USA, UK, even UK Met Office, so our India, we have two high resolution 12-kilometer ensemble prediction system. They have 2018. So there is a huge scope of using this ensemble prediction system. And of course, now we have tested the 6-kilometer. If we get the new HPC by end of this year, we will go to 6-kilometer. But other countries are not investing because their mid-latitude system and they are happy with that coarse resolution. For our tropics, we need high resolution. But the advantage is being a global model, it produces forecast for the whole globe. So somebody can take this forecast and make money by selling it to different Pacific region, Australian region. So this is one of the very exciting things, and this data is available. I am sure if you write to NCMWF or IMD, this data is shareable. You can do research on this. So this is the global ensemble prediction system. Similarly, regional ensemble prediction system, we have 4-kilometer 11 member. That's also a very big data set. And this data also is shared with ECMWF. If you register there on the TIGI portal, you can download our data along with 10 other ensemble products. So our is the very highest resolution. So people are publishing paper by downloading this data, making studies on severe weather, which severe weather can be predicted. So many multiple years of data is available now at ECMWF, this TIGI portal. So these are some of the example of the ensemble prediction system. What I was saying earlier, see, there was a single track prediction, deterministic. So now you see the probability in terms of percentage. So when we say that it is going to hit West Bengal government will spend maximum resources to take care of their life and property. Whereas Andhra and Odisha, you see, it gives a probability. The probability that it will hit Andhra is how much? 20 to 40%. So they will accordingly spend. And so this is very useful in cyclone. We have started using it because the cyclone forecast is very successful, and the probabilistic forecast, the cone of uncertainty is given to all state governments, and they are using it. Same thing we have to use for heat wave, cold wave, and temperature, all other things, rainfall. These are some of the standard, very interesting plot. So this is the cone of uncertainty, from the start, where it will hit and what is the percentage probability to hit which state. So these are all available on our website in real time whenever the cyclone severe weather comes. So I will skip all these things. They are all related to severe weather. So this is again the cone of uncertainty. So how the recurring cyclone it gives. Yeah, this is one of the very interesting. Recently, it hit Andhra Pradesh. It got weak, but our model was predicting very good. All other models were saying no, it will recur and go away. Even IMD gave the official forecast. TG साहब ने टीवी में बोल दिया कि recover हो जाएगा, but Andhra में touch कर गया. But luckily it was already weak. So this Andhra disaster management people were in touch with us, and they liked NCOW forecast. And anyway, so again, why I'm telling, I'm not blaming IMD. So the uncertainty is there. So instead of giving a forecast confidently, it will go away, nothing will happen to our Indian coast. You can tell if one model is showing that there is this much probability it will hit Andhra. So instead of giving one forecast, you have to now give, this is the probability that it is going to hit Andhra by this much, 30% chance is there. So they will take care. Yeah, ECMW also was showing that it will go to Andhra. Anyway, so this coupled model, because it is coupled to a ocean, it predicts very interesting thing called tropical cyclone heat potential. So that particular Andhra system, why it came to Andhra, there was a lot of heat in the upper ocean lying there. So in a coupled system in the ocean, you can compute all this in tropical cyclone heat potential. Yeah, these are some of the other example of rainfall. How you can give probability. What is the probability that it will exceed 11.5 centimeter? So you see the probability here from a global model and a regional model. So regional model naturally does better. It's giving 75% more probabilities there that it will rain more than 11 centimeter. That's the Kerala rain. This is the observation. Again, rainfall example is there, probability of some mountain rain. A very good prediction was there, but you get the probability. You can tell. Yeah, now the new thing is now a lot of people are dying in thunderstorm, this lightning. So the regional models, WRF also has this lightning scheme there. So in our website, you can see the lightning probability also is given. So this is observation, and this is ensemble mean. And of course, we have not reached the end. Disaster management authorities are asking that they want at district level, block level. It cannot be given now. So only a large scale, broad area we can give. So this is the area observed. A lot of lightning was there, and it was predicting that this is the area it will have lightning. A lot of biases are there. So a lot of research again here is there on lightning prediction. Yeah, again, example of ensemble prediction. So I will stop here, but I think I will need at least half an hour later sometime because I am here today and tomorrow, because this is equally interesting. And so what I have covered is the weather part. This is the multi-week and seasonal prediction and the ocean part, sea ice part. So if you can find out half an hour for me anytime today, out of the schedule. If yeah, for me, I'm here. So then I will stop here, and then I will continue from here. So any question or discussion briefly we can have if you have very pressing one or two questions. And next time, whenever there is a free slot, I will come back from here and finish in next 30 minutes. Thank you.
Okay, thank you so much, sir, for your informative session. May I now request Professor Sri Krishnan to please come forward and felicitate our honorable guest with a lovely memento. Thank you so much, sir. Ladies and gentlemen, now it's time for lunch.